And I'm just going to call it October 14th. We're going to leave it as Postgres version 17. 18 is now out, but it's preview. So I want you to stick with 17 till it's out of the preview mode. So right now we're going to just use 17, which is the default. Leave it on Amazon Web Server. Make sure it's Northern Virginia because that's the closest to New York. And don't check anything. Just we're selecting the defaults. Only thing is you're giving it a project name, and I'm gonna say create. And once it's been created, and I can see all the projects I have just by going back to my organization, and you can see I have my October 14th, and last class I had created October 8th, just again, fairly quick, and you can, I think, 8 or 10 projects or something like that, you can set up for free. So this is different from what we did with MongoDB, where you really were limited to just one. Once you have a project selected, I'm going in, you can connect to it, or again from here, you can look up the connection string. So if I do that, I'm getting the basic information. Don't worry about the branch, which will be main by default, and that's how we want to leave it. The database name is NeonDB. We can change it, but that's what it is right now. And the user, they're calling it role, but this is basically user name. And just leave it as default. There's no reason for you to go around changing these things. Don't change any of the defaults, and the only thing you need to worry about is the connection string. And for that, you need to be able to see your password. I'm going to get out of my connection string, and I'm going to go on the left, and I'm able to see SQL editor as well as tables I've created. So you have two ways basically of making changes. You can go into SQL editor and make changes, or you can open up pgadmin and use that. So going back to our note from last week, I had given you these additional notes and handouts, and I've told you right now, ignore this one. The flow chart on Draw.io, ignore it. It's a couple of weeks away. And this and this, that's what we should be focused on right now. So I'm going to go back to this document, primary and secondary keys with referential integrity, and I'm going to bring it up. So this is the document that you should have. And we had gone through the process of creating these tables in the last class. And I briefly had mentioned primary key and secondary key. So I'm going to explain that in a little bit more detail next. Primary key is typically what would be just the ID of that column. So the reason you have a primary key is that it uniquely identifies each record. So no two rows can have the same primary key value, and it cannot and should not be left null, empty. So each table can have only one primary key. Now, it is possible to use 2 or 3 columns, combination of that, to come up with a primary key. But for what we are going to be doing, and that's what they mean by a set of columns, for what we are doing, we are going to just have one column and we'll have a primary key. A primary key should be something arbitrary. It's not something which is supposed to mean something. So in this class, for example, imagine I was setting up a table and getting your information, and a table would be nothing more than, I'm going to open up Excel now. So a table is nothing more than this, and the column names are going at the top. So having a column called ID, and then let's say I'm keeping track of your first name, last name, phone, and email address. So imagine I'm trying to keep track of these columns, and I have added the ID column so I can uniquely identify each row. So in here, is there another column that would be good as a primary key? And possibly email. Email might be good as a primary key. Why am I saying that? Nowadays, everybody has their own email, and like you're not typically sharing an email with a family member or a sibling or a spouse. But if you go back 15, 20 years, often people were doing that. There was one email, and the husband and wife might be sharing it, or a family might be sharing it. Nowadays, no, that is not happening. Maybe you could use something like an email as a primary key. And in on websites, they often do use email as a username, which is almost like using primary key. However, is it possible that 2 people will end up with the same email? Is it possible that you have set up an email that, let's say, a husband and wife are sharing? Answer is yes. And you want to avoid a situation where 2 separate rows here will have the exact same primary key. So typically, if I am setting up database, and I'm gonna show you an example of it. So let me do it through, um, let's go to Gemini. Okay. So I can ask, how do I ensure that email is unique in Postgres? And it will give us guidance on how. So you can add a constraint called unique. So imagine we are creating a table for users, user ID, and it's generally a good idea to set something up like this, arbitrary primary key. Should not have any meaning. Then we might have a username, email. And now when we are talking about email, look, we are saying that it should be unique. So we can add a constraint that to make it unique. And this is how it's done. Okay, so add constraint, and basically the email ought to be unique. So you can do that, but even then, I would not recommend using email as a primary key. Even in this example that I have created through Gemini, what is happening? They're giving us an example of how you might create a users table to assist with somebody logging in. So a login table might have a user ID, might also have a username, might have an email. Sometimes they eliminate username and email is the username and password. But notice, even in this case, you are making it unique, but you're still creating a unique primary key, separate. So again, in terms of best practices, not what you can get away with, but in terms of best practices, it's always a good idea to set up a primary key similar to this, something unique, something arbitrary. It doesn't have to mean anything, and that's probably the best way to set up a primary key. So with the primary key, and give me just 1 minute. If there are any questions, do let me know. I'm just reviewing questions students have sent. Okay, so somebody, one of the students commented that some organizations like pharmacies will let two users have the same email address, and yes, it is possible that that is the case. So just going back, we want to make sure that whatever is the key in here is unique. So is it possible, again, if I'm just keeping track of information, that two people will have the same first name? Yes. Two people have the same last name? Yes. Is it possible that two or more people are sharing the same phone? Yes, it is possible. Same thing with email. Nowadays, phone and email tend to be unique. In the past, that was not the case. There would be one phone number for the entire family. So things can change and shift over time, but what you want to do is add something arbitrary, and a good example is what we see in here, that you're creating a primary key and we're using this thing called serial. Serial means that we want the primary key to be auto incrementing integer. So it will start off at 1 and then 2 and 3. Nobody's entering a number. So if you say user ID serial, that means you want by default auto incrementing integer value. And when I'm saying auto incrementing, it is possible that it will skip a number. So you may be going 1, 2, and then it skips and goes to 4 or 5. And I showed you an example of it last week. It doesn't mean it will necessarily stay the same, 1, 2, 3, 4, 5, 6, 7, the same sequence. No, it can skip a number. All it's saying is it will automatically come up with an integer and it will be unique. But typically it's doing it by automatically incrementing it by 1. The other option when you're creating a primary key, and I'm gonna, let me just see, let's do another one. So how to create a users table with UUID as primary key and unique email in Postgres. Okay, so I'm now telling it I want not serial, but something called UUID, and just watch what happens. So it's still going to create a user table, but now it's not using an integer or a serial. It's using something called UUID. And it's still primary key, and it's saying by default, generate a random UUID. And I'm going to say, show me an example of UUID value. What does a UUID value looks like? So universally unique identifier, and it's now going to explain whatever that means. And the example is what I want you to see. So you will see something like this. It consists of numbers and it consists of letters. And the letters basically are typically from A through F, which is 16 base. So again, we're going to see an example here that it will generate something and so everything here is a sequence of numbers and alphabet letters. And when you're talking about alphabet letters, they are A, B, C, D, E, F. So again, you're not seeing anything beyond A and B, but if I generated more and more, so that's typically how it is created. And again, it's going to look something like this. Only thing important for you is that it looks something like it's not just an integer. It's a combination of numbers and letters. And one of the reasons that you are generating a UUID is that unlike serial, where if I am creating a table and you are creating a table, we may both end up having 7 as a user ID. When you create these UUID, they are universally unique. And we say universally unique across space and time, meaning that any two computers, I'm generating a UUID, you're generating a UUID on your own, they will end up being unique. Your ID will not conflict with mine. So if you have a situation where you need to decide what two tables or two values might be merging. So one person is going to be working on one set of data and creating their own database. Somebody else is going to be working on another set of data, creating their own database table, and you're going to eventually be merging them. In that type of a situation, you may want to use something like this instead of integer or primary key. So it's basically telling us it's typically represented by 32 hexadecimal digits. So I'm going to ask it, what is a hexadecimal digit? How does it differ from a regular number? Okay. So a hexadecimal digit uses 16 unique symbols to represent values from 0 to 15, which means it basically is giving you 16 values, 16 numbers. So we use 0 through 9 and then letters A through F. So there's no difference now between hexa and decimal value when you're looking at 0 to 9, 0 to 9. But to represent 10, instead of it taking up 2 columns, it only takes up 1, and we use the letter A, capital or small caps. That's not important. So the letter A means 10, B means 11, C means 12, D means 13, E means 14, F means 15. So you use basically what we call a hexadecimal. It's base 16 versus base 10. The typical number system we use is base 10. Here it's different. So the regular number system is base 10, which we use every day. And for computer usage, it is sometimes more efficient to use base 16. Why? Because eventually, at least the current computers are based on base of 2. So, they're based, what is binary base number system? So the way a computer understands it, it's using basically 0, 1, 0, 1. Why? That's me. Okay. The way computers, and you must have heard of this previously, that the computers use a binary number system 0, 1, 0, 1 for everything. Because it's an on, off. That's the way the circuits are set up. So from a computer science point of view, yes, we eventually need to get everything down to 0, 1, and it's easier to do computations using a hexadecimal system than a base 10 decimal system. So again, I just want you to have to basic idea of these things, and this is why you use hexadecimal with UUID. So there are various ways we can create it. I'm going to go back to my notes now. So primary key, you will be creating it typically using either serial, which is really another way of saying integer, or you'll be using it creating the UUID. And I will tell you on an exam, use UUID or use integer. So that's one thing for you to keep in mind when you're doing a primary key. And now I'm going to get into secondary. So a secondary key, and I'm going to go in here. I want to add one or two more points. One of the reasons we want this to be a unique value is if we need to delete, imagine you have a bunch of data over here and you wanted to delete a specific row. The easiest way to do it is by ID. So I know, okay, so this is 1, 2, 3, 4, 5, 6, and I want to delete this particular row. So I can just say delete by ID, where ID is equal to 5, and this row will get deleted. Now, I'll call this table customer. And now for this customer, I want to keep track of sales. Now, I'm going to just make this customer John Doe, and I'll make it 212555123 and Jado at qc.edu. Let's just now, if I'm selling something to this particular customer, I could come in here and duplicate this information. So imagine I have something like this, and again, I'm going to delete in just a second. So in here, I could just say, okay, John Doe, and he bought something. So I'll just enter sales amount. And here I'll just enter the date. Actually, let me do date in the first column. So it's now October 14th. Uh, so I could say, okay, on October 14th, John Doe came and bought $53.12 worth of stuff. I could keep track of it this way, but this is not a good way of keeping track. Why? If some data about John Doe changes, I have to then update it here and here. So, for example, he doesn't like the name Doe. He decides, okay, I am going to change it to Smith. Can somebody do that? Yes. He doesn't like the name John. He may change that, or there may be a reason for him to change it. But whatever the case might be, so now it's John Smith. And all of a sudden, you have to duplicate, you have an inconsistency in your data because you are keeping track of duplicate data. This is not a good way to organize a relational database that we are now working on. So in this case, a better way to do the same thing would be, I'm going to modify a couple of things. So I still want a date field. I'll also add a ID field, a date field. And instead of keeping track of the customer by name, I'll keep track of the customer by customer ID. So here I would be better off entering 1. Let's get rid of this column. So if I know he's changing his name, or more likely the name, somebody may change their phone number and email address. Okay, so if it changes, we don't have to keep track of it in multiple places. Everything is kept only in one place. You do not duplicate your data. You do not add redundancy to your data. When you have to make an update or a change, you only have to do it one place, and all your other records are updated automatically, because everywhere else you're going to use the number 1 to reference John Smith. You are not keeping track of it where you would be, and here, let me just make, where you're keeping track of it by name or something like that. And that's how it's done. It's typically done. And like for Queen's College. Now, this ID is not the same as this ID, and it's arbitrary. So here I could be using, it is okay for me to use this, or I could be using, let's just start with 101. I can start and do anything. And now imagine this customer wants to buy something from us again. So the ID would now be 102. Let's say he's buying it now on October 15th. And I need to make sure it just keeps the format the same. Okay. And it's the same customer. So I just keep track of it by saying, okay, it's customer ID 1. Now he bought something worth $65. 65.33. And if another customer comes and buys something from us, so this would be Jane Doe. And again, I'm not going to bother with phone number and stuff like that. So Jane Doe wants to buy something. I will keep track of it as follows. So this is 103. And let's just say it's 10-15 as well. And the customer ID now is going to be 2. And she buys something worth 96.45. I am making up just these numbers. So you would be keeping track of this being primary ID. This is primary ID. So I'm going to just call it PK. We often abbreviate it to PK to indicate primary ID. And in here, this is primary key. Now, in this other table, we have a primary key, but we also have a foreign key. But it's better to refer to it as a foreign key. That's like the standard terminology. So even though in my notes, I put foreign in parentheses, it's, I think, probably better to refer to it just as a foreign key. That's used much more frequently than the term secondary key. So foreign key is the primary key of another table. So in this table, what is the foreign key? The foreign key that's what it is. It's the primary key of another table. And what is its purpose? It's used to cross-reference. It's used to indicate here that, okay, this was John Smith, that this was Jane Doe. That's it. So going back to this one, secondary key, often called foreign key, is used to create a relationship between two or more tables, not just two tables, two or more tables. It refers to the primary key in another table. So the foreign key must be a primary key in another table. It is used to ensure data integrity. So it's used to make sure that, imagine I did something like this. Sales transaction 104, and I'll just copy the date. And I put down 3 over here. And I say 101.21. Now, I have right now instantly violated the constraint. Do I have a customer with an ID of 3? As of right now, the answer is no. I don't have anyone with an ID of 3. And it's possible that the system even skipped a value, one value in between. So it looks more like this. I am not sure why we are going in there. I'll just say clear format. Okay. So imagine this is perfectly fine for primary key. 1, 2 jumps, 4, 5, 6. And I do not have anyone with a primary key of 3. And by doing this, imagine I add this, it indicates that there is some sort of an error. There is no customer which has a ID of 3. This would be what we are calling violating the constraint. So if you look in here, you know, when we are using this, it is used to ensure data integrity. It is used to ensure that the relationship is actually valid. And when we did this, let me just come down and see if I can find an example. Okay, so right here, so we had two tables, an accounts table and a transaction table. And so think of it this way. This is a customer table, and then this is the sales table, sales transaction, and account is basically the customer. So now in here, we are saying account ID, which belongs to the this particular table. Okay, this account ID, it references account right here. And that's what we are defining it. And basically, by doing this, by adding this particular references uh, word or this particular constraint, then we are telling it, make sure that any value that's entered here is coming from this table. Don't let somebody just create a value here without this. And that's how we basically ensure referential integrity, data integrity. So in this first handout that I had given you, this was something I did not go in the last class, primary key and foreign key. We did do these transactions. We had gone through this. So I next want to go, and it's basically asking, you can look through these questions. How do you make sure that there's referential integrity, how it's done that, and we use this references clause. And I think that is the end. No, it keeps on. Okay. So it's just going to explain in my notes. I forgot that I had this, but it just explains in a little bit more detail what I mean by referential integrity. I've already explained it, but it's going into it in a little bit more detail, and you can try it out. And one of the reasons you want to have referential integrity is also imagine that 3 did originally exist and now I have deleted 3 out. So with referential integrity, you can make sure that if I delete a customer, like in here I deleted 3, that is also automatically deleted from here. So, and that's called cascade delete. And it just explains that a little bit in this. So when you're deleting, uh, or it will tell you, no, you cannot delete it because it will violate a constraint. So there are different ways that you can enforce referential integrity. So we had gone through this, we had done it, and I didn't, this stuff here goes into it in a bit more detail, but this is not something I'm planning on doing in class, these particular exercises and stuff. But it's there just so you have it and you can do it. If I assign something on an exam or you're trying to do something in real life. Okay. Any questions so far? Let me know. And I'm going to be switching to the next slide or the next handout. Any questions? Let me know. So the next handout builds on this, and on your end, if you go into the notes section, I just finished covering this one. What is the primary key, secondary key, referential integrity? This is what we had started in the last class. I just finished this particular discussion. Now, I'm going to be getting to this part. This is the critical part. This is why we are discussing all of this, because when data is stored in multiple tables, so like in here, I'm storing data here, here, so on and so forth. When data it's stored in multiple tables, and let me get close this out. I'm going to bring my other one in, which deals with the joins. Okay, so I had opened it up last class also. Very briefly, we had talked about what is SQL and all that. And my purpose really was to discuss joins. That's why I have this. So joins are basically used to join tables. So if you were looking at something like this, you want to know who one is, and you can achieve that through joins. So you can issue a SQL command saying, I got this particular table, join this table with this table, so that I'm able to see the names of the people who bought it or the email addresses of the customers who bought and when they bought. I want to put this stuff together, and that's what joins are able to do. So when you're doing any type of data analytics, working with database of any type, you really need to understand these concepts of join. So if you were using any type of a data analytics software, you're pulling data in, even if you don't know directly, behind the scenes, they want you to phrase your query in such a way that you are utilizing joins. That's the way it is. Anywhere you're trying to accumulate or gather data, select data, etc. So I'm not going to go into this about the real world analogy, but I do want to talk about a sample database set, a basic example. So imagine you have a student's table. So we have student ID, name, and their major. And then we have another table, which is looking at enrollments. So for the cell biology course, who is taking it? So enrollment ID is yet another table. We are keeping track of the various courses and who is taking that particular class. So this enrollment ID is the primary key for course name. And obviously student ID is the primary key here. And in here, this is the foreign key. We're calling it student ID, student ID. It is possible I would have just called it ID here, and I would have called it just ID here. So it's okay to call ID here and call it student ID here. Nothing wrong with it. Or the names can be the same, and that's fine as well. But this is your foreign key. So these two tables are connected using this primary key and this foreign key. Now, when you want to join two tables, so student ID appears in both columns, this is the connection point. When you want to join tables, there are a couple of options you have. And this is the concept I want you to understand. This is what I will test you on as far as the theoretical part of the exam is concerned. So right now, your next exam, exam 2, is just a hands-on. You're going to be creating a database, entering data, etc. It's not focused on these joins and stuff like that. So you know what your exam looks like. Actually, let me go in from here. So this is your exam 2. And basically what you're doing in here is working with Neon Postgres database, PG admin, and I'm giving you, instructions of what you're going to be doing. So yeah, I'll have you create a table, insert some data. I'll have you do some query. Now, when you're doing some query, I'm having you do a simple example of what is called an inner join or a left join. And that is what I'm discussing here. What is meant by an inner join? What is meant by a left join? And we have other types of joins as well. There's a right join, there is a right join, and then some of these have identical or different names. There's an outer join. So we're starting off with joins. So I'm again gonna go back to my Gemini. I'll open up what are the different types of joins in SQL. So in SQL, you have inner join. Now, left join is sometimes called left outer join. Right join is sometimes called right outer join. Full join is sometimes called full outer join. So there's what we call inner join, and then left and right. And really, there's no difference between left join and right join. So when we are looking at joins, you're joining two tables together. I'm going to bring up a new sheet in Excel. So this is a representation of a table. I have my customer table, and then I have a sales table. And I'm going to now do sales and customer. So imagine I have this, and I'm joining this table with this table. And I may use the term, I'm doing a left join. This with this. Now, whatever result I'm going to get, and you don't know about it, I haven't taught you that exact same result can be done if I said I was doing a right join on sales and customer table. So left join and right join, there's really no difference between the two. There is a difference between inner join and outer join, but left and right join basically just refers to if you've got two tables. And really, order doesn't matter. Which table is, I'm going to use the term, the main table, okay? And what is the secondary table? So a left join here between these two or a right join between these two is the same thing. A right join here is identical to a left join here. So right join, left join, you don't need to worry too much, except just know that they are essentially identical. So what do you need to worry about? Really, there are three types of join: inner, full or outer join, and right left join. Three types instead of four. And here they get into how you create inner join. And inner join is the most common type of join. So even here it tells you inner join returns only rows that have matching values in both tables being joined. This is the most common type of join. So when you are doing using SQL, typically you may not even realize when you're doing a data join that it is automatically doing an inner join. You may not even realize it. Okay. If you're using some software for data analytics, you're extracting data and you just say, yep, take values from this table and this table. You're telling it you've got two tables. I want to get values from this and this. So it will automatically or by default do an inner join. You may not even realize that it's doing so. And what it's basically doing is saying only include records that satisfy join conditions in both tables. So let me see. Show a Venn diagram to explain the different types of joins. So now you might remember set theory Venn diagrams, and I'm asking it to create basically like a diagram to show how this works. Okay, so here is a Venn diagram. Let me see. If I can zoom in a bit. I am trying to zoom in and it's doing the opposite. Let me download it. And I just want to zoom in a bit. So SQL joins explained. And let me also go in here and send you this particular item. Uh, and again, this is not a very good name for it, but so I'll just change the, let's edit the properties in place. So SQL joins Venn diagram. So again, this way you have it, it's an image, but let me open it up on my side. So what are these different types of joins? So imagine you have table A and table B. So table A and this is table B. So when you are doing inner join, you are returning data that is matched by both. When you are doing a left join, and I want to switch to PDF as well. Or rather, let's go here. So when you're doing inner join, it will find the matching values between both tables. So with the diagram that you're now looking at, it will find the matching values in both tables. I am losing track. Okay. It will find the matching values in both tables being joined. And this is the most common type of join. Often, this join will happen by default. You may not even see the term inner join being used or saying, just happens by default. In a lot of software where you're trying to retrieve data. Now, left join or left outer join, same thing, different names, but exact same thing. So now we are going to go over three types of what we are calling outer joins. The left join returns all records from the left table and the matching records from the right table. So going back to my image, a left join. I'm not actually seeing this too clearly. Okay. So a left join will select all records from table A, which means this, and matching records from table B. So if this is the table B, it will generate whatever. This is the matching record. So this, and again, this data is coming from this side. In right join, you're just doing the opposite. So allows all rows from table B, which match with rows from table A. In a full join, you're retrieving everything from A and everything from B, including whatever is matching. Visually, this thing will make more sense once you actually do these examples that I have in my PDF. But I'm going to go in here. So a left join, all rows from the left table and only matching rows from the right table. Right join is the same thing. Right join is all records from the right table. So what we mean by right or left table is nothing more than which table you are putting, first and second. That's all, nothing else. So there's really no difference from the point of view of what data is going to be coming. Depends. But with a full join or a full outer join, you are returning all records from your left table and from the right table. So it's combining basically the results of left join and right join. Okay. There are additional types of joins like self join and cross joins. We are not going to be worried about either of these two. They exist, but they're very special purpose. Most of the time, 99%, you are not going to be running into it. So, and if you don't know, what type of a join you need, you can always use AI and have it generate the join. So, or you can ask AI, what type of a join is it? again, and let me just switch A and B. Or I'll call it table customer and matching records from table sales transactions. So I don't know what type of a join I need, but what I want, basically in English, I want to get the names of all the customers and where it matches the sales transactions. So, and I don't know if it's an inner join or an outer join or a left or a right, and I can even tell it generate SQL statements for me. And in general, the SQL statements are the same, whether you're using Postgres or some other database. But sometimes there are minor differences. So if I'm using AI, I will specify generate SQL statement for me for Postgres or for Neon Postgres, but it's just Postgres. It's fine. So because I may need something different if I'm using a slightly different database. So imagine I issue this type of a command and it's going to tell me what type of a join you need. So from what I described here, to get all records from customers and only the matching records from sales transactions, you need a left outer join or a left join. So this type of a join will get all from the left table and only matching from the right table, so on and so forth. And if there are no matching rows in the right table, the columns from the right table will contain null values. And I wanted it to generate a Postgres SQL statement for me, and it is doing that here. And it's creating basically what I'm calling like a generic statement, meaning instead of calling it the customer's table, it's saying in here that I am abbreviating customer to C, just letter C. Why? Because when you're trying to do S dot, you're going to be using that type of a syntax. It just sometimes becomes very long. So imagine over here it said customer dot, customer ID is equal to sales transaction dot, customer ID. It becomes very long. So what it's doing here, and this is very common, that we'll rename the table internally. So saying, instead of calling it customers table, let's just call it C. And instead of calling it sales transaction, I'm going to be calling it ST right here. And that's what they're doing here. So again, I'm giving you this so that when you have to deal with it, I want you to rely on AI, and this is free that I'm using, a very basic model. Okay, you don't need anything more complicated. All of these AI systems, even the very basic ones, are very capable of generating SQL statements for you. So coming back here, and I'm gonna go back up, and I have maybe about 5-6 minutes left. So I'm gonna just highlight what I'm giving you in here. So the data that is coming in here is coming from these two tables. And when we are doing a join, and we are starting off with an inner join, we are saying return records where the values here are going to match the values here. So I have 101, 101 twice. So this student is taking biology and chemistry. 102 is only taking world history. And 104 calculus, 105 physics. So let's see what we're going to get. So based on this, we're trying to combine this table and this table using these values. So these are, so if you're using inner join and the actual SQL command, it's something that's shown over here. Like, what are we doing? What will it return? So my formatting is off. I realized it afterwards, but you can still see this is where the table is. So we're starting off with the course name, and then underneath, so name and course name. So the name of the student is Allison. What courses is she taking? Cell biology and chemistry. Then Bob Smith is only taking world history, and David Brown is taking calculus. And you are able to see this very quickly, visually, if you're just looking at these two tables. Now, student ID 105 does not exist in here, which that student is taking physics. So that data does not exist when you're trying to join two tables together. Student with enrollment ID 105 does not appear. Why? It doesn't, she's not enrolled in any course. Well, this particular table that's being generated is looking at what courses a particular student is enrolled in. And so again, in here I have examples. You can see each one. What happens if it's a left join? What will show up as far as data is concerned? So in a left join, we are getting Carol White. We're getting all the students, but she's not taking a class. It will show up as now, but she will not be excluded. Her name is also showing up. What happens in right join? So the results are shown over here. Again, I'm like now going through a bit quickly because I just got a minute or two left, and you have the handout that you can look at and then actually see what is happening. And you need this, and you can, and there's an example here. You can type this in. I'm giving you, an example that you can work with and with to see what will actually be happening. So just look through these notes because you do need it for the exam. For this portion of the exam. Now, I also here you and again, you're allowed to use, I'm saying answer by writing SQL statements, and you are allowed to use Gemini or ChatGPT or whatever to assist you, just like you see me do, what I did over here, but I'm also giving you an idea of how you're actually going to be creating things, how you're going to be inserting it, what type of joins. It's giving you all of this. So as long as you just sort of read through it, you will be good. I'm not really having you to create or do things completely on your own. I'm having you do things in a very, what I'm calling a guided way. rather than just doing things on your own. Now, this stuff does get tested at a theoretical level, not just what you're doing here, um, because it's part of chapters 5 and 6 in your textbook. So when you have a quiz or an exam on chapters 5 and 6, you're going to see this stuff again, but you'll now be tested at a theoretical level, not at a practical application level. Any questions, let me know. Otherwise, you can disconnect.